So the big upgrade first was we jumped to Blender 2.93, so we support that now. For people still on 2.92, we still support it. It's still there for you who wants to use it, but the one we primarily support on the website now is 2.93. The new parametric system is in place. So what this means is that when we rebuilt everything from scratch and to use native IFC, we built editing tools that were very raw, very, very detailed. You had to edit every single aspect of your building information one by one. So let's say you want to draw a wall. When you draw a wall, there's a lot of steps involved in drawing a wall. First, you create the wall itself, then you create the geometry for the wall, and then you have to create the data for the wall, like its quantities. Then you might also include an axial line for that wall, so that you know where the material layers start from. So you say that the outermost layer starts here, and then it goes inner layer. And then you might also generate an extra plane for structural analysis. So there's all of these separate steps which happen when you draw a single wall. And then when you draw two walls, you have to repeat all of those steps again. Then when you join two walls together, you have to, again, make all of these adjustments. And we take this for granted in our BIM programs that you can just click the wall to and you go click, click, and ta-da, I have a wall. But because we rebuilt everything from scratch, you couldn't take that for granted. And you actually had to do every single step manually. You had to create your wall, update the representation, update where it was in the building. So is it in this floor of the building or that floor in the building? And obviously, that's not a very pleasant experience. It's good to have that fine-grained control as an option, but you don't want that to be the default option. It's pretty poor. But you need to start with that, because that's how systems get built. They start from very manual things, and they slowly get smoother and smoother and more stable. So we slowly built in more things like automatic synchronization. So many things were just happened in the background. You didn't need to think about it. But this is the first time we started doing actually parametric authoring. So what that means is that when you create a wall, it calculates a lot of stuff already for you out of the box. And to do that as well, there is a new project library system, because in the past you'd have to create all your wall types from scratch every single time, and that's incredibly slow. And that's not how people work nowadays. Nowadays people have asset libraries, and that's how they can create things so easily. Imagine if your BIM program didn't ship with asset libraries and you had to create your pipes from scratch, your doors from scratch all the time. It's a nightmare. So we're just getting these features in place, which is really exciting, because this starts making you realize, oh, BlenderBIM can do this. So if I just load up this library, for example, and I'll pull in a couple walls, I'll bring in a 100mm thick wall and a 200mm thick wall. Now I can, I have this editing tool, and you can see how I can do various things with my walls. Let's say I want to switch to my ground story of my building, and that's my wall that I've just drawn in. And I can say, all right, let's extend the wall out to there. And along with that wall, it's already put it in my building story. It's already given it a layer thickness. It's already, and once we'll call this a wall.ifc. You can see it's calculated all the quantities for it. It's also worked out that it has a bounding box. It's all calculated already. And this is something we take for granted, but it's something that we need. So we now have wall creation. So now, for example, if I go and create another wall, you can see it automatically worked out that it's a 90-degree attachment to that wall. So I can go take that wall, extend them out here, go add another wall. And let's say I want to extend we'll take this wall, extend them out here, and I'll just duplicate that wall here. And let's say we want to change that to a miter joint here. Great, now we have a miter joint. And you can see how simple and...
How did you do that? I'm getting dizzy here. How did you do that?
Sorry. Well, you can see there are all these little hotkeys. So that's another thing we're doing, that the features were all there, just you had to press buttons and it was all one by one. But now it's all built. Now we're shifting our focus, saying, okay, the feature's there, let's make it a good experience. So you can see that process just now is very similar to what you expect from existing BIM applications, right? It's not too different. And I can pull this one out. I can do half manual things. So here I am manually pulling this one out to, let's say I'll put it exactly 2 meters away. And again, I can take both of these and let's give them both miter joint connections to that wall. You can see it's extended and done the miter joint connections on both of them. So this type of smooth experience, same thing. If I go and switch my wall type and put a very thick wall in the middle of it, and let's say partition it, let's partition that one as well. It's just easy. It's smooth and easy.
I agree. Oh, I have one question before you go further. The first wall which you modeled, you needed to load it from your computer, right? Because it is not in the library.
Correct. I loaded the asset library. I loaded, and in my library, and you can see here, well, I don't have my library loaded anymore, but I did have it loaded, and I loaded in a wall type. And you do that anyway in your existing software, or it comes bundled with types.
Yeah, but that's not why I'm asking. Because if somebody will try to use BlenderBIM, they will not have access to this library because you have this on your own computer, right?
Yeah, this one, correct. But we're starting to distribute them and working out a way to distribute not just walls, but also columns and beams and standard profiles. So if I bring it in, you can see I've got a few. I'll bring in some columns, and I'll bring in a slab, and let's say a beam or so. And then you'll see me use them. But you're right. We do need to start distributing these, and we will. Right now, you can create your own semi-manually in the same way that you would create your own manually in existing software. Like you create you create a new wall type, and you say this wall is X thick with a layer of this, with a layer of that. So you can do all that right now, but that's boring. It's easier to just click import and and get something on my computer. Yeah. But anyway, as you can see here, it's all kind of parametrically updating, which is really exciting. I can also start drawing things. So if I wanted to, I can. Well, here I am. You can see I've got this sort of strange thing I can sketch here. Let's see this. Let's see that I'm going to draw a little kink in here for whatever reason, and then we'll switch back to my walls and do the thin wall. And there we go. So now I have a whole bunch of walls created out of my sketch. We'll go and basically start fixing up some of the. This one is I didn't draw it very neatly, so I'll just align it. So there's all these kind of wall alignment tools. Fix a junction over there, fix a junction here, create a T-junction, butt junction over there, and there we go. So we have, let's say we wanted this to be exactly, I don't know, 2 meters away from there, done. So everything you're seeing here is not new. They existed before, well, sort of. But the new thing is that it's now easier to use, and there's hotkeys, and it's slick, and all this type of stuff. So
more user-friendly, easier for new beginners, and it looks like you don't necessarily need to learn Blender, because this is another quite high entry point for anyone willing to try it.
Yeah, correct. It gives you the power of Blender, but let's face it, 99% of the time you're drawing boxes. Who wants to draw boxes again and again? Let the computer draw it. That's not where your creative passion is, drawing boxes. No. Let the computer do the dumb stuff, and you can focus on the beautiful shapes. Anyway, I'm talking from an architectural perspective, of course. Yeah, so I guess this is, walls are one thing, but of course there's a lot more than walls. So for example, here I am, I've just created an opening within that wall. So this little cute hole over here, which, let's just, I don't know, make him a bit bigger. And, I can toggle my openings on and off. And we'll throw in a couple of columns as well. So I'll take a column, and let's put a column over here and put a, bug. So ignore the bug, but you can see the column appearing. So I've got a few columns here, some rectangle, these ones here. Obviously, we should fix the bug. I'm not sure if that's a new bug or if that's just one on my local machine. There you go. But I guess what I want to show is that everything you see here is, again, just like the wall parametric. So this particular I-beam, for example, has all of the data you need. So you can see it has this currently an unknown material because it's just a test library. You can see all of the web thickness, the flange thickness, the depth and width of this I-beam. It's not manually modeled. It's all parametric. So if we want to make this like a square type of thing, I can just change that. And if you ignore the bug, which is the same bug as before, you can see it's updated to be a kind of a universal column more than a universal beam. And just ignore this bug, which keeps on cropping up. It's the same bug again and again. Anyway, it gives you an idea that we're slowly getting to the point that it becomes easy to author, and out of the box, you get quantity takeoff, structural analysis, and it will work for all of the next systems which we throw into it, which we'll get to in a short while. But I guess that's the first bit, which was parametric behavior, which is really exciting because many people think that IFCs are not parametric. This is not true. They most certainly are parametric in certain ways, not in other ways, but it can be. Many people don't realize that IFCs can be used not just as a project, but as a project library, as an asset library. So we can basically bring in objects from
the library in different projects. Yeah.
Yeah, or reuse. If we have a project that we're currently, you can import that as an IFC. So in fact, I'm going to test this here, and let's hope this bug doesn't bite us. So let's see, documents, where is it? Downloads, I think this one. So let's see if, I'm not sure this will work. So we'll just bring in, okay, how about this armchair, chair? Well, that's the same bug, but let's see if it works despite that nasty looking message. No, sorry. No, I guess it didn't. That's okay. That's because of this. Let me see if it's something unique to my session. So I didn't save it. I saved it before I added the columns. But let's see if this will work. Let's bring that chair. No, I've got to fix that bug. All right, pity. I wanted to show some nice stuff, but there's a bug in the way.
It's fine. It's going to be on the next release, I guess.
Correct. We now release every single day, so you can.
Okay.
Yeah. Maybe we should mention that more.
Yeah. That's a quite important detail, I would argue.
Yeah. So basically, every couple months or 1 month, we just do a stable release, and by stable, I'm telling a lie because it's not actually stable, as you just saw. It's basically a line drawn in the sand saying, you know what, let's just release. And at the very least, you can install it and it will run, or most of the time. But that said, there is this thing called developer build. So things change so fast. Every single day there are new changes. Like on the homepage, you can see just all that yesterday, the day before. Every single day there's new fixes and updates. So if you click on the developer build, it will bring you to this scary looking page, but that's okay. You just pick the one which works for you. You pick if you're on Blender 2.93, which most of you are, or above, pick the one which says Python 39, and you choose your operating system. So you download it and you just install it. There you go. And see, this was released 23 hours ago. And there'll be another release in another few hours.
Yeah, all right. So, but on the website, you have only the stable releases, right?
Yeah, make-believe stable. It's not really stable. It's
no. I was quoting it, but it was not visible.
Yeah. So this is the place to get all the cool stuff as we fix.
Okay, interesting. Awesome. That's very nice tip. Thank you.
In fact, that's something we are starting to do, is actually document this, which is great. We're getting to the stage that we can actually start writing instructions, because that's a common problem. You say, oh, let's try out BlenderBIM, and you don't know what to do. And that's because we're too busy writing code and nobody wants to write English words. But we're getting to the state that we're starting to write things like installation instructions, upgrade instructions, and developer guides. Anyway, what were we talking about? Yes, so parametric features.
Yeah.
And yes, cost planning and sequencing tools. So this is kind of one of the things we promised for the Epic proposal, was that we're going to cover everything, and that includes, I guess you'd call it 4D and 5D, right? Costing and scheduling. So this is another thing which ISC can do, which many people aren't aware of. It can create a cost schedule directly, integrate it with your model. No linking, no imports, exports, any of that stuff. So we have, I guess, where are we? Work plans, work schedules, work calendars, cost schedules, resources. It gets pretty deep. So I'll give you a little demo here. We'll blow up the screen to make it easier for people to read. So here we are. We'll create our workday calendar, and we'll say that this calendar we are working every week, Monday to Friday from 9 a.m. to 5 p.m. Great. So this is something that you get in tools like Microsoft Project or P6 or Asta Power Project or Synchro. Guess what? Now we have 100% free software to do it as well. We create our calendar and it's full IFC. This is our 9 to 5. And let's create a new holiday. So we'll call this New Year's Day. And this is something that happens yearly on a specified date. And we'll take the January the 1st. We'll just have a holiday then. And yes, save that. Great. And then we can create our work schedule and a work plan. And we'll start with our schedule and create a couple tasks. So we can do something like, build foundation or something like that, create a subtask, and we'll do excavation and, task 1, task 2, whatever it happens to be. So this would be the beginning of your construction tree. Work schedule, yeah. And so there's features for generating Gantt charts, assigning objects. So we can say, I don't have a foundation here, but I can just select all that. And let's say this half of the building is, this task, and this half of the building is that task. Great. And let's change my columns. Let's add a new schedule start column and a schedule finish column. So we'll do start and finish times. I'll make that a bit smaller, and we'll do starting from here to, let's say, so we take 5 days to do that. I can do a duration column as well somewhere. Duration takes 4 days. I haven't assigned my calendar yet. I probably should. So I'll assign my workday calendar to that. Great. I have my workday calendar assigned. Yeah, so this is pretty typical functionality that you see in existing software. We can generate our Gantt chart for it as well, which, as you can see here, is the world's most boring Gantt chart because there's only one task.
Where do you get this? Do you get it on your local machine?
Yeah, that's right.
Okay.
Yep, a little interactive web page thing. But of course, it's a bit more advanced than that. You can see in the screenshot, you can see some finish to start relationships. It calculates critical path, early dates, late dates, floats, and relationships and subtasks, and all that type of nasty date calculations that will do your head in. But great, it does those kind of things now.
Interesting, very interesting.
Oh, and same for costing, but costing is a little bit less developed. You can create things and assign objects and create cost items off them, but it's pretty basic. But we'll add one. Let's throw in a cost item, so we'll call this walls, and we'll assign this guy. And let's say we're costing this is a partition wall. So yeah, the side area is good. So this has 18 meters squared. Don't mind the meters cubed over there. That's just made up stuff. We haven't, that text is not yet working, but the number works. The text is just placeholder. Anyway, so let's say we have a rate of $5 per meter squared, which gives us a subtotal of that. And you can do formulas and sub cost items and stuff like that, and cost rates. But yeah, so a whole bunch of new toys have come. There's some stuff to do with resources as well. So you can see, I guess you call this plant in some existing software. But yeah, it's still just starting, just getting there, but getting more and more. Oh, and animations too. We can generate little animations of our building being built, which is nice and exciting. So if you want, we can build the world's most boring animation. Sure, let's just animate January. And if we animate it, well, there you go. I've only put dates in for the first bit, so it's only animating that. It says something's happening here. And I haven't assigned it to be a construction task, so it's just coloring it this way. Because it differentiates between construction, demolition, renovation, or logistical things. Yeah, so lots of new toys coming in.
Interesting. How much time are you putting in to develop these other features than focusing on 3D modeling and everything else?
Half. Not sure. Things change. I think the thing about open source development is that it's a messy process. You don't really have, I guess, targets or bosses or any of that. It just, whatever happens because somebody wants it to happen. And you don't get to tell people, you don't really get to tell people what you want to happen. You get a bit of influence over it, depending on the culture of the community. But really, it's a messy process. Somebody might work on something for a bit and then disappear for a year and then come back later. And that's okay, because it's still better than if they hadn't done anything at all. So it's a bit hard to give a straight answer to that.
Yeah, I understand. But most of the focus anyway. So there is some interest in the other features as well. But now tell me something else regarding this. How is this smarter? How does this leverages IFC, and it is better than the other tools existing out there?
Simple. No import export. Your data is standardized. It's the same reason why native IFC is generally a smarter thing to do than black box BIM or traditional BIM, because you lose your data if you do it black box. Whenever you import and export, you lose your data. Even within the same program, you lose your data. You can't access your data. Here, not only do you have full access to your data, you have freedom to interpret it however you want. You can build your own tools around it. Your data doesn't expire. There's no import and export process. You don't have this model linking that you have to keep on keeping track of. Every time there's a new model being released every 2 weeks and you're falling behind, you just work together. You have, imagine every single discipline all working with the same language. No, transmitting all the time and having imports and exports and filters and people being out of date and only half the data being sent and the rest being hidden. And then after the job is finished, all that data disappears. All of that goes away.
But there is still an issue. Sorry for interrupting, because you say that everybody works in the same file, with the same elements and such, but you don't have access live. This is not somewhere live updated. You still need to exchange files, right?
Well, not necessarily. IFC was never designed to be specific to a way of exchange. Yes, most of us use IFC files, but you don't need to. People don't realize this, but you don't need to use that. You can treat IFC as a database, as a shared central server, for example. And you can all work on it interactively all the time.
How do you do that? Let's say that you and me want to work on the same project. You do the architecture and the structure. How are we doing this? How do we set up this to work?
Well, there are a few paradigms which exist. None of them have been built for IFC yet, and maybe in a future release we'll have that really interesting discussion, and we'll do a thing where you're on one computer editing and I'm on another computer. I don't know when that time will be. A few months, a year, who knows? But it'll happen one of these days. I'm almost certain about it. But there's a few ways of working about it, just like programmers
like Git, something like Git,
exactly.
Right?
Git can be one option where they're synchronizing in a decentralized fashion, or you can have a centralized workflow like SVN for those who know SVN, or it can be streamed for those who are aware of how the streaming and locking system works. There's quite a few techniques to solve that problem. A simple one like this here. This is the IFC data, but it's viewed on a web page, not BlenderBIM anymore. It's the same data, but in a web page. Now, for those in the audience who's looking at my address bar going, Dion, this is just a static HTML page. You're right. I haven't built it yet. But in theory, there's nothing stopping the fact that I can be interacting with the exact same data, half through this Gantt chart form on a web page, and the other half through this visual kind of 3D Blender interface. And whether that's on one machine or three machines, it doesn't matter.
I'm wondering about why do you think Git it's not optimal or it's not ideal for IFC? Because you said that you will think about something that should be designed specifically for this.
There are two problems here. Git is designed for tracking plain text changes and not huge plain text changes either.
Mm-hmm.
And it's great for that. And that's what programmers need, right? They edit plain text and it tracks it.
Exactly.
Git is not very good for tracking binary changes. So binary would be things like image data or model data. Yes, IFC is plain text. You can open it with a text editor, but it's not very clean when you edit it. When you start working with native IFC, it becomes a huge amount cleaner, like crazily cleaner. When you do a big import-export, that's a mess, right? You have no idea how things could turn out between one export and the next. But when you do it natively, it's a lot cleaner, but it's still not clean enough. Like when a programmer reads the changes, there's 2 points of the synchronization. The first is to actually just keep track of changes, like an undo system. But the second is to describe the changes. And Git was designed to describe it in 2 ways. First, by a simple text message. We have a discipline in the programming industry to write a short description of changes. So if we go back to BlenderBIM add-on and go to the repository where everything is tracked, you can see how whenever somebody makes a change, there's a little sentence that's written describing why they fixed it. And so we don't have that culture in the BIM industry, in the AC industry. Whenever you make a change, you just press, save, synchronize.
Mm-hmm.
You don't write down what you changed,
Mm-hmm.
and which is a bit of a shame, really. But the other half of that is that, okay, let's say somebody wrote down something. You want to see what exactly they changed. And here, if I click on here, I can say, oh, he added exactly that one line of code, and that fixed this. Whereas for models, it's much harder. How do you visualize that? Yes, some of us can read the matrix that is the IFC source, but most of us cannot read the matrix.
Mm-hmm.
So we need to be able to communicate that change. And that's the difference between a system which just keeps track of your things so that you can press undo, and a system which actually describes your changes. Nobody has cracked that so far in the BIM world, to be honest.
Yeah, but it took some time until Git came out for the programmers, right? So we need something similar.
There was stuff before Git. Before Git, there was SVN. Before SVN, there was CBS. So version control has been around a long time. Very, very ancient technology. The AC industry kind of just, it's crazy. It's crazy. We work on such complex systems and we don't use it. Yeah. But we are getting close to starting to solve it. One of the things that we're doing in native IFC is creating a high-level API of changes. So every time you make an edit within here, it's not saying, change lines 3, 5, 6, 20, 53. It's not like that. It doesn't work like that. Whenever you make a change, it passes through an API. And this API is specifically designed to break down the complexity of the relationships of IFC into meaningful tasks that anyone can understand. What I'm showing here is a bit nasty. And there's a lot of gunk here. That's because I have a bunch of weird debugging stuff because I was testing a few things. But I'm going to highlight a few lines that are not debugging stuff that will hopefully make some sense to you. So over here, I added a new resource, a subcontractor resource. You can see here is the line which says, I create a new subcontract resource. It's a little bit hard to read, but it's not too hard to read. See? Resource. Add resource. Subcontract resource. Here's another one. Edit cost value. Okay, I'm editing a cost value with a new applied value of 5. See, it's not crazily hard to read. Here I'm editing cost value, walls. Let's see another one. This is assign cost item product. That's where I assign wall to wall. That was when I was clicking here and clicking that. And effectively, this is the beginnings of a way of meaningfully describing in a standardized way exactly what changes are being made to your native IFC. And this is, again, an industry first. I don't think anyone has quite divvied up the IFC graphs the way to the extent that we have, and it's really exciting to see because it's a really difficult problem. How do you describe all these interconnected changes happening in a really simple to understand way? And yes, this is really ugly at the moment, but for those who are keen-eyed watching this video, I think you'll recognize that there's potential here in creating very meaningful change descriptions that humans will understand.
Yeah,
ignore all this type of stuff. This is just debug stuff.
This is awesome thing, man. I'm really looking forward to see the development of this in a few months or years.
Yeah, definitely.
What do we have further on?
Well, there's structural support, but I'm like the wrong person to talk to about that because I'm not a structural engineer. I can try bringing the file if I even remember where this file was. Building 01, maybe. Oh, here's a cute structural model. A little tiny one, not the big tower you saw just now. You can see that the point connection has got some curves and planes and yada yada. And then maybe if I click on things, it might show me some properties. Well, I'm not entirely sure here. Where's the structural boundary conditions? No boundary connections. Okay, connected members. This is the coordinate system of that connection, right? So I can change. I don't even know. Maybe structural engineers might appreciate some of this. I'm not very good at this. This is my structural member axis. Okay. Let's see here. And then there's some loads. Okay, we have some loads and some load cases, and Look, I won't pretend to know that I understand how this stuff works. A lot of this was written by one of our contributors, Ioannis. Ioannis. It's pronounced with an E. Sorry, although it's spelled with an I. I make that mistake. So it just shows that please, anyone can join in, and we really, really welcome new contributions.
So, but let me ask you something. Do you think are there many structural analysis softwares that you can export to IFC?
Yeah, I probably shouldn't mention proprietary software much in this video, just in case.
But there are some at least, right? So they try to go in this direction. I mean, it looks good. It's interesting that because it was not so easy actually to share data between structural analysis software and design software, right? It was not easy at all, and not even between, or not even talk about different softwares of structural analysis. It was the same issue.
That's right, and you couldn't view it either. That was a terrible thing. You could, like the thing I'm showing you right here, there was no viewer for it. It just didn't exist. You couldn't see what I'm showing you here. Well, maybe there were some, like I'm sure John Merchant, if he's listening here with his Geometry Gym add-ons, who was trailblazing for a very long time, he's probably built it. But there's not a lot to choose from. And so it's really good to see these things so easily with free software that anyone has access to. And even before, like the schedule, an architect can be working their BIM model, and let's say somebody's using P6 or MS Project, they can just go, okay, import P6 or MS Project, and ta-da, they can see the work schedule there in their model. It's starting to really integrate disciplines in a really exciting way. So there's been a lot of bleeding edge openBIM stuff happening with the Google Summer Code students. So we got 2 students, Artur and Prabhat, one working on the information delivery specs, and the other one working on BCF XML3 and BCF API.
Sorry for interrupting. You told me about Epic Games, but you did not mention too much about Google Summer Code. What is this?
Okay, so Google Summer Code is a program by Google where I think every year students or recent graduates can apply to contribute to an open source project. And there's a list of open source projects that are listed by Google. And this year, the BlenderBIM add-on and the IFC OpenShell was one of them. We're under an umbrella organization known as OpenCAX, basically like Open Computer Aided something. And you can see there are the FreeCAD's also in there, BRLCAD, OpenSCAD, and basically a student writes a proposal saying, I want to contribute in this way and build this thing for that project. And we had 2 students for IFC OpenShell, and the other 3 projects also got a bunch of students allocated to them, and Google will pay a stipend for the students' time and mentoring time. And it's a great way, especially during their summer vacation, to learn something and get paid and I guess get a lot of experience out of it.
Yeah, sounds very good.
Anyway, that's Google Summer Code.
Yeah.
Cool. Now what?
Is this were these the most important features of this release?
Well, that was the previous release. Then we have this release.
The previous. I meant with the previous releases.
Yes. The stuff the students are doing are really great as well. For just like to introduce something known as the Information Delivery Specification, in short, IDS, and it's a fancy way of saying what are your exchange requirements. So whenever we exchange our BIM data, you'll notice people saying, "Oh, make sure this parameter is filled out with these values," or little requirements like that. And you have all these model checkers. And the problem with these model checkers is, firstly, they're black box. We don't really know how they're checking, or can we trust it, or they're expensive, so only certain people with the licenses can check them. And they're hard to share. They're not in a standardized way. It only works for that one software. So this specification is a way of saying, all right, here's a really simple way, and it's an XML file for those interested, of the most common exchange requirements. So things like, does property exist? And then you can run it on any model checker, not just one proprietary one, or that the previous one worked with, but any model checker, and you'll get a report of all the results. So that's a really interesting project. There is already prototype support with it if you want to check it out here in BIM Tester. So you just select you choose your IFC file, then you choose, in this case, the IDS file that you are given, and then you just press execute, and you'll see the report come out. I don't have a file handy, so I can't show one, unfortunately.
Interesting.
The other one is BCF. So BCF previously, BCF is being upgraded to a new version, which fixes a few things from the old version. But one of the nice things is that it has much better API support. So instead of exchanging files, you can communicate directly within your BIM application to whatever your issue tracker system is. And I guess, without having to leave your application. And that's really exciting. So the first step is to build a library which supports it. And soon we'll start seeing a way to integrate with these cloud platforms through their APIs.
Sounds interesting, this one as well. This is something like it was available already, but for paid solutions, of course. What do you mean by creating your own library? Library of...
Well, actually, no, it wasn't available. The 2 things I mentioned, IDS and
BCF. I was thinking about the BCF, not IDS.
Yeah, they were not available. What was available was BCF XML, which is the file-based import-export. But the API, the version 3 API in general, well, maybe there's a few people out there playing with it, but generally it's not available. There's not a lot of support out there right now. And this is one of those kind of bleeding edge technologies that I guess you can start playing with now instead of waiting. Same with IDS. IDS, there wasn't any software out there because it's new. It's just brand new. In fact, not even released, probably. Oh, well, sorry, there was a recent release, but I have to double check. Was that final, or they're still tweaking things? They're probably still tweaking things.
That's good. That's very good that we get progress on these fronts as well.
Yeah, I think we try to do that. We try to mix between pushing the boundaries of what's possible, and the kind of more, we have to build a wall tool.
That sounds good.